Everyone okay? All right, chapter 1. This is it. This is the start of the foundation of the house of management science. These 4 chapters are all linked together. After we get past these 4 chapters, every chapter is a self-standing house. It's like a job. But these 4 chapters are the foundation to all the jobs you're going to learn about after the 4th chapter. What can I tell you? Management science is all about you reading, or you at a meeting, for example, and talking about some big decision that has to happen. We got to make this decision. But there's all these different things you got to take into consideration, and there's so many things to take into consideration that you're trying to figure out which would be the best decision. This first chapter is all about you taking that scenario, turning the decisions that need to be made into variables, and then taking the variables and taking the words and making them into equations. Mathematical equations using the variables. Everybody hear that? So this is all about taking words and making them into math equations. This is the hardest part. This is why I got to make sure it gets through to everybody, because this is the building block. Chapter 1 builds up. Chapter 2 is how it's solved. Chapter 3 is how to analyze it. And chapter 4 are real problems that are much bigger and a little harder to figure out what the equations will be. Let's take it easy to start with. Here's all we're going to jump to. Look at this, all the stuff you're reading at home before you got here. All right, got that. We're jumping to this car one. As I read this car example, this first one's just about figuring out an equation that will determine the price that we should start the auction for this car. This auctioneer wants to do that. All right? Before I do this, okay, no, let's keep going. Hope I don't forget what I was just going to do, because right after this, I want to review how to calculate profit. If a company wanted to calculate profit, what are the steps to do so? We're going back to your accounting 201, but I want to make sure everybody remembers how to do that when we get done with this one. This one, you ready? We're going to read the situation, figure out what the variables are, or variable, and then write it as an equation to solve it, so that every car that comes up, we can quickly figure out how much to start the bid. It says the auctioneers, I'm going to put in my own words. How's that? You ready? This auctioneer said, hey, I need a quick way to figure out what I should start the bidding at. And the auctioneer says, I can see a connection here. Every time a car, where I want to go right here. Where's the percentage? It says essentially he starts the bid, okay. He wants to set the starting bid at 70% of whatever he predicts the final winning bid is. So he looks at what the final winning bid is for a whole bunch of cars and says, what do they have in common? What they have in common is almost all the cars are having a deduction from their original sticker manufacturer's price by about $800 for every year old it is. So this is 2019. If it was 2017, it'd be 2 years old. $1,600 would have to be subtracted. So there's something that's been noticed about all these cars have been going through. Whatever their age is, $800 per year. Also, this auctioneer figured out that there's about 2.5 cents for every mile on the odometer being subtracted from the original price also. And that's about how much these cars are going for. The starting bid has to be lower than that. Matter of fact, it has to be, what percent was it? 70%. The starting bid, this auctioneer says, if I could set this up that would calculate that winning bid estimate, then multiply times 70%, that's where I want to start these bids, and this could roll faster, and not make mistakes. So here we go. Let's see. What would be the winning bid? Let's start with the original price. Right? Here's the original price of a car, whatever it may be. Now, what am I going to subtract? Let's say we don't know how old the car is. We'll make that a variable, year. So turn that now into a variable with a number. We need to subtract however many years it is. I'm going to enter, it's going to say Y for year. So original price minus year times what? You got it. There you go. Now we got to subtract mileage, which is 2.5 cents, 0.025, times a variable, which we're going to call M, for however many miles. We plug in the original price, we plug in the year it is, or however many years old it is, and we'll plug in the mileage. This will give us, right, what will most likely be the winning price. Now we take this whole thing and multiply it times 0.70 or just 0.7, 70%. There is our starting bid. We just took our problem and we went ahead and set it up as an equation, and now we have it all set up on Excel, and the next car is coming up, we plug in how many years old it is, we plug in the mileage on the odometer, we plug in the original price of the car when it was new, and we have our starting bid, and we start the auction. So what's happening is right here. 800 times the age, 2.5 cents times the mileage, gets subtracted from the original price. Then we take that whole thing, multiply it times 70%. 70% times P, we're doing algebra now, 0.7P. 70% times 800, 560. 70% times 2.5 cents, 1.75 cents. You do not have to apply the algebra. You want to leave it in this format and then say, okay, the rest of the problems are now going to tell you what year the car is, what the mileage on that car is, and the original price, and you have to tell me the starting bid. You can leave it in this format and just plug those in and do the math. This is an example of what you should expect coming up on your quiz, where you're told this story and you need to come up with this. In the first quiz, I give you the variables, but we have to get to where I'm not giving you the variables. You have to come up with the variables. Okay, so this first quiz, every one of these stories, I'm giving you the variables. Do not even attempt to use any other variables than the ones I'm giving you to you, because there's no reason to. I'm giving you every variable needed to solve the problem, to be able to write the equation that would solve it. So that's what you're going to get, is a story, and then at the end of the story it's going to say, let A be the age of the car, let M be the number of miles, and let P be the original price. Now write an equation that will determine the starting bid. You got to come up with this, using those variables. Get it? That was too easy to start with, kind of. Right? Now I want to try another one. Okay, before I go on to the next one, I want to review how to find profit if you're looking at a company's numbers. First thing you're going to get is, let's say this company says, we sold 25,000 items and our average price was equal to $25 per item. Our variable cost for every item is costing us to make that item about $12. But before we even start making the first one, we have this overhead, this investment we made, the loan on the equipment, the building. So we're starting in the hole at, hang on, I got to remember, 10, 20, and these, let's say we're at $310,000 per year fixed cost overhead. All right, I'm going to give you the variable. Variable is going to be X. X represents how many we are going to make. I want you to tell me an equation using X, using these numbers, that will tell us how much profit is. Talk me through it. What am I starting with? What's the first number on like a income statement? Sales or revenue? Sales and revenue. So what would that be? 25,000 times what? $25, right? 25,000, isn't that what we sold of them? Times $25? Oh, this is given? Dang it. That's why everybody's not talking. Thank you. $25 times X is our revenue. Then what comes next? What are we subtracting? How much? 12X. 12X, because it's $12 each one. However many we're making and getting that revenue, we had to make and spend $12. One more step, minus 310,000. We're in the hole 310,000 before we even make our first one. So it's revenue minus expenses equals either a profit or a loss or a break even. This is all heading for you to tell me that at this point we're heading to where you would do this exact same thing, but you would want to calculate the break even. How many would we have to make and sell to get this to equal a 0 here? And that's how you do it. You take this whole equation, make it equal to 0, and that's how you calculate the break even. Then you use algebra to get the variable by itself. So here we go. I'm going to do it exactly as I just described. 25x minus 12x minus 310,000? Yep. 10,000 equals 0. I'm going to add 310,000 to both sides. I get, thank you. I'm going to subtract my x's. How many is that? 13?
13x.
X equals, subtract, so we get 310,000. Divide both sides by 13. There's my break-even point. That's your refresher for accounting. All right? Everybody on board now? We're all set? All right, so now, that takes us right here. This company is building one type of house. It's like a, what is it? Like a log cabin type of house. They're called Ponderosa Development Corporation. They sell this house for $115,000. $115,000 includes everything. All right, $115,000. Now, while you imagine this, you're the builder. There's certain things you do before. There's certain responsibilities you have before you ever even sell a house. But there's certain money you spend, and you don't spend it until you sell a house. Once you have the customer and they make their down payment, now you start doing all these activities to get this house built. Remember that. There's a difference there. All right? The money you're spending without even selling the house, that's your overhead. The money you're spending once you sold the house, that's your variable expenses. If we were to sell a house, it'd be $115,000 in revenue for each house. Here's our expenses. Land for each house, $55,000. Are we going to buy that land to build that house on before we sell the house? Nope, not at all. Just thought I'd throw that in. Lumber and supplies, $55,000 for all this. Other materials will run another $28,000. Are we buying these other materials before we sell the house? No. All right, afraid to answer now. Because the other one. Labor costs, $20,000 per house. Do we pay labor before we sell the house? No. So we have all those variable costs. Now it says we have office space at $2,000 a month. Do we pay for office space before we sell the house? Yes. Yes, there's one of your fixed overheads. Cost for supplies, utilities, the leased computers and copy machine we lease, $3,000 a month. Fixed or variable? Fixed. We have to pay it even if we don't sell the house. The one salesperson at the company get a commission of $2,000 for each house sold, or fixed or variable? Variable. We don't pay unless the house is sold. And we have 7 permanent office employees who per month, 16, 20, 25, 29, really, is it that many thousand? How much is it? $35,000 a month. Does that count as a fixed or variable? Very good. Total cost, here we go. Land, material, the labor, the sales commission come to $105. There's your total variable cost. All those salaries have to be paid, even if we don't, and the lease on the equipment and the rent on the building, $40,000. Is that right? Is that it then? There's our total cost. Did I get it backwards? Or does that include everything? No, that's our total cost. So think about this. What will be the variable, and let's say it's X, but what does X represent for a month? How many houses sold? Now we're going to write it as an equation. Revenue, help me out. What would revenue be as far as X is concerned? What? What number goes with X for revenue? 115,000 times X. There's revenue. Now we're going to subtract the variable cost minus what number goes with X for variable cost? 105,000 times X minus our fixed cost, which is how much? 40,000. What we want to know is what does X have to be to get us to 0 or a break even? How many houses do we have to sell just to cover expenses or we're losing money? And you would set that up in an equation, just like this. Here's our revenue. Here's our cost, the 10,000. Well, where are we? Here's our cost, 105,000 for each house plus the 40,000. We combine X's, the marginal gain, the amount of money we're making on each house, the marginal profit, it happens to be 10,000 per house minus the fixed costs. It's obvious, this is very easy. You're all doing it in your head right now. How many houses, help me out, how many houses to break even? 4. You got it. Very easy. Okay? Don't be wrong, some of these are not going to be so obvious. You're going to have to use the algebra. If this were going one more step, we would set it equal to 0, add 40 to both sides, then divide both sides by 100 or by 10,000, you would see it'd be 4. Now, if you notice on Blackboard, this was set up there. You may want to have this right in front of you while you're taking the quiz. This is using Excel to do the exact same thing we just did to find that break-even point. Up at the top where it says fixed cost, let's use the Ponderosa. What was the fixed cost? 40,000? Yes. You enter that in. Right here, the variable cost per unit for every house sold, it was 105,000. All right. Selling price for each one was 115,000. Is that right? Yeah. There we go. This is where we want the quantity that we will need to sell to equal, hang on a minute, we want this to end up being 0. Because right now, we have no revenue, because production's at 0. We have the 40,000 in overhead, no matter if we sell a house or not. So our total loss is going to be 40,000 if we sell 0 houses. I left instructions over there, so you can play with this when you download it. And you go to, I forgot already, data. Go to the data tab. Go to the what if analysis, is that correct? Look, go to the what if analysis tool, then it says select goal C. Go to goal C. Now, this says set cell. The set cell is where you are putting the number of either profit or loss that you're trying to get to. That's right here at D17. Let me get there, hang on a minute. What's going on? D17, by clicking on it at D17, you want to know when D17 is at 0. What will it take to get that cell at 0? And by changing what cell? You're going to be changing how many to produce, right there. So there's D11. Okay, now watch it. It goes fast. Are you ready? 4. To get that to 0, you have to have sold 4 houses. See how this works? Again, if these are more complex numbers, it'd be a lot more handy. It was so obvious before. Okay, now we're going to throw a twist. All right? This is a twist. Those were easy. All it was one variable. You set it up like it's going to be a break-even formula, revenue minus expenses equals 0. Now you're being introduced to linear programming. Linear programming is where if the variables are not being given to you after this first quiz, you got to figure out what the decisions are that have to be made and set them to variables, called the decision variables. You have to realize, what is the purpose of this? What's the objective? The objective always has one of 2 things. Either we're trying to maximize something, or we're trying to minimize something, and you have to have one of these 2 words as part of the objective function equation. Because you're using one of these 2 words, for the objective function, you do not make this equation equal to, less than equal to, greater than equal to nothing. Never use the greater than, less than, or equal in an objective function. Okay, all right. Hang on. But in the other equation, these are equations also. Nice. Come on, here we go. Is it Friday? Michigan, thanks. Good job. Constraints. Those are equations. They're always have an equal, a less than, equal, or greater than equal. Let me repeat that, because the equal is all 3 options. Less than equal, greater than equal, or equal is the only 3 options for the constraints. So you're going to read problems, you're going to say, now here's my hint on constraints. As you're reading a problem, keep asking yourself, is that a limitation? That's the word I always put to constraints. It's like a limitation. Sentence will say, and Department A only has 40 hours available. It's trying to tell you there's a limitation involved. And you would say, let's see here. We got these two products, and they both got to go through Department A, and there's only, how many hours did I say available in Department A? 40. So there's only going to be less than or equal to 40. You guys over there, do you see that? Less than equal to 40, because there's only 40 hours available over there. How many hours will that product take in Department A, and how many hours will that department take? Because however many of that and that we're going to send through Department A, and however many hours they're using up, got to be less than or equal to 40. Has to be. That's a limitation when you're reading this. You're going to write an equation like that. You read that X spends 2 hours in Department A if we're making X's. If we're making Y's, it spends 3 hours. However many, and X represents how many of that product we're supposed to make during this next shift, this week, coming up. Y represents how many of this other product we need to make during the shift coming up, which is a week long. We're planning production. We just found out we only have 40 hours in Department A. These have to go through Department A, B, C, and D, and right now in A, with only 40 hours available, how many hours does X spend in it? 2. Y, 3. That's such a limitation, it's going to limit how many of X's and Y's we're going to make, so we have to have the perfect combination to stay within all the limitations that exist, and to make sure we make enough to get them to our customers, because we never, ever, ever, as much as possible, we don't want to let our customers down. We don't want to put them on back order. Odds are, if we put them on back order, they're just going to turn around and get it from our competitor, which we spent all this time being slightly below their price to keep this relationship. That's how important it is. So we have to figure out the exact right production that meets all the limitations that you're going to read, even in just one problem. So this is how it is. You just saw an example of a constraint. Now let me talk about an objective function. An objective function, you're going to read something that says, it costs this much for every X we make, $6. And for every Y we're going to make, we're spending $7. And management wants our costs to be as low as possible this next production run. That's the goal. Max or min? Min. Because it's cost, and management wants it to be as low as possible. Min. Now we're going to write an equation not equal to anything, not less than equal, not greater than equal. What equation represents what we're trying to minimize, which is our costs? However many X's we're going to make, let me go over here so we can see it. However many X's we're going to make cost $6, plus however many Y's we're going to make are going to cost $7. And when we have production set up, we can put a number there and a number there, and when they're added together, it's going to be whatever numbers those are, needs to minimize the total cost. Now right away you say, well, let's just make all of X's. That's the least we can make it, right? Everybody hear me? Let's say you can only make 10 products. What would you make? What's the combination? How many X's? How many Y's? You can only make 10, and the goal is to minimize cost. How many would you make? 10 X's. Your mind goes right to the least price. But there's other constraints that come into play. For example, one of our customers has already ordered 3 Y's. You get it? So however many X's and Y's, Y has to be greater than or equal to 3 because we want to make sure and get this customer order filled. There's how we take the sentence. Our customer has already ordered Y, and they expect 3 this next manufacturing shift. All right, so we know we got to make 3. Now, if that's the only limitation, and management wants the cost to be as low as possible, and you only can make 10 items, how many X's are you making? Everybody hear that over here? Yeah, what they said, I didn't hear any over here. 7. What you just did in your mind is you said, well, X is a lot less expensive than Y. Why don't we just make all X's? But there's this limitation, a constraint that says we have to make at least 3 Y's. If we can only make 10, here we go. By the way, if we can only make 10, X plus y must equal 10. Wait, at most. See how I just changed it? You read the sentence. However many you make must be 10, that's an equal. However many you make cannot be more than 10. However many we make has to be less than equal to 10. Now, what you just did in your mind, you said, well, if all I can have is 10, and I'm trying to keep the cost as low as possible, and I want to make sure and get this customer to 3, you decided that you're going to make 3 of the y's and 7 of the x's. Is that right? Did I say this right?
Well, you could just make 3 y's and that'd be it.
Or that'd be it, because I put that less than. Exactly. Now, this is really what you were doing. What you did in your mind, when this becomes very complex. In the real life, I've experienced, there was like, 20 variables and 100 constraints. And, there's only one objective one, whatever the objective is. And in that case, you can't just look at this and have conversations and say, oh, if I'm making 3 of those, I'll make 7 of those, and da-da-da-da-da. This is where linear programming has come to birth, is because these are too complex to just do real quick in your head. What you're going to do in your head, though, when you have tons of variables and tons of constraints, is what Excel's going to do for you very quickly, but it's too complex for us to sit there and stare at it and get it solved in a minute. Do you get it? How are we doing on time? We got lots of time? Good. Don't forget, I need, what I say, 5 minutes to pass that stuff back, right?
Yes.
All right.
Pass out attendance too.
Huh?
Attendance.
Thank you. Did you say attendance? Can someone start a sign-in sheet? Does anybody up front here got a piece of paper that you just sign and pass it around? You got it? Chase, you got it? He's already, you got it right there? You got it? He's doing it. But he's not going to take it. That's the bad news. All right? Okay, let's look at this. I want you to help me come up with, I'm going to give you the variables to start with. S are sofas, C's are couches. Okay? I'm going to, before we even get started, S are sofas, C's are couches. If I said to you, write an equation that will just tell me how many couches and sofas we're using, what would the equation be? Blankety blank, blankety blank, plus, minus, divide, help me.
Working with the constraints in the problem.
Yeah,
already.
forget this problem.
Oh, okay.
Ignore this for a second. S is sofas, C's are couches. Just give me an equation that will tell me how many of each you've used. Together.
XC plus YE.
No X's. The variables you use are only the variables you're given. C and S. S plus C, it will tell me exactly how many you're using. Right?
Yeah.
All together. This is where you got to get your mind. Every question I ask, you got to use the variables and kind of logically say, how would these variables be represented in an equation to represent the exact question being asked? Are you ready? For example, the store has 800 square feet. They're going to put some couches and sofas in. And however many sofas being used in this display is going to use up 50 of the square feet. However many chairs, I'm sorry, what did I say, couches? I meant to say sofas and chairs. However many chairs, sofas and couches are the same thing, I think. However many chairs is going to use up 30 square feet. Okay, you got that so far? All right. We cannot go over 800 square feet. Let's just start with that. We cannot go over 800 square feet. Less than equal to 800, greater than equal to 800, or equal to 800. We cannot go over 800 square feet. You got it. Less than equal 800. You identified a limitation, and you identified what the words of that limitation represent. We cannot go over 800 square feet. We can go less than 800, and we can go 800, but we can't go over. Is it just my eyes, or do you get darker? I'm having a heart attack. Could you call 911? I don't know what's going on. Okay. Ready? We want to write a mathematical model that represents a store's constraint, because they only have 800 square feet available. However many sofas and however many chairs, when added together, cannot use up any more than 800 square feet. But wait a minute. S doesn't represent the square footage of a sofa. It's just how many sofas. I have to represent the square footage being used by each sofa. So what do I do with the S?
I turn it to a 50.
That's 80 S. Is it 80?
50.
Thank you. 50 S. this is off camera too, but I'll say it real loud. So far we got 50S plus, how much square feet of the chair using?
30.
30. However many sofas we're using, however many chairs we're using, times their appropriate square footage that's going to be used. Don't worry, the square footage includes the space needed around it. Has to be less than equal to 800. That's it, because that's all space we have. You just wrote a constraint. You took the words. This told you it's 50 square feet for a sofa. It told you it's 30 square feet for a chair. It told you there's 800. This 800 is what identifying the limitations all about. Is saying we're limited to 800 square feet. And we turned it into a mathematical model using the decision variables. The decision is, how many sofas should we put in this display that's 800 square feet? How many chairs? That's our decision. And then we read, every sofa we sell is going to be $200. Every chair is $100. We want to write a mathematical model, one objective at a time, because there can only be one. Let's pretend management says we want the total pieces, we want to maximize the total profit. Okay, max or min?
Max.
Max, because it's literally giving you the word. Now, don't forget, no equals to, no less than equal, no greater than equal. It's a mathematical expression that will represent what we're trying to max, which said profit. We're using the variables sofa and chair. Help me out. What number goes with sofa?
200.
200 times however many sofas,
Yeah.
plus
100C.
100 times however many chairs, when added together, is what we're trying to maximize. That will maximize profit. If this problem said, write an objective function that maximizes profit, you wrote it. Get it? But let's say that's not there. Instead, it says, management wants you to maximize the total pieces of furniture in that display. Think about it. The total number of pieces in that display. Max or min?
Max.
Max. What do I write next?
50S plus 30C.
No.
Oh.
It doesn't say to maximize the square footage, or you would be
Oh,
well
right,
over
right,
it.
right.
It says instead, maximize the number of couches and sofas in the display. Not all at once. No, that would be profit. Wait, 5. Where'd you get 5? Hang on.
Says at least five.
At least 5 sofas.
Yeah,
Oh, I passed those, didn't I? We're coming back to that.
Yeah.
We're coming
8
back to that.
would it be-
Forget about the 5. I accidentally passed those. And how many chairs? At least 5 sofas, 5 chairs. Forget about that for a minute.
Wouldn't you start?
Objective function is about maximizing the number of sofas and chairs in the display.
800?
No,
That's plus C.
there it is. The variables are representing the number of sofas and the number of chairs. You didn't need to put numbers with them. There's no numbers that tell you how many. That's exactly what the variables represent. Maximizing S plus C. However many sofas, however many chairs, if this were the sentence in this problem, that is written like that. Yes, the variables are in the objective function, and yes, a lot of times you have to put numbers with them, but when you put numbers with a variable, it's because you're converting the variable to whatever it is you want it to represent. You want it to represent profit, we're putting the numbers 200 and 100 with it. If you want the variables to represent square footage used, we put the numbers 50 and 30 with it. But if you want the variables to represent how many sofas and chairs, you don't put anything with them because that's exactly what the variables represent. The other limitations, how are we doing on time? We're okay. The other limitations are at least 5 sofas. Hang in there. At least 5 sofas. You ready? 5. Less than equal to 5, greater than equal to 5. Or equal to 5. At least 5 sofas. At least 5 sofas. Greater than equal to 5. However many, and then what's on this side? What represents the sofas and the number of them we're going to use so that it's greater than 5? S. S, greater than equal to 5, because there has to be at least 5 sofas in the display. Then it says there has to be at least 5 chairs in the display. Less than equal, greater than equal, or equal to 5. Greater than equal again, at least 5 chairs, right?
Yeah.
You gotta make sure. At least 5 chairs. What's on the left side?
C.
You have a constraint to make sure chairs, at least 5 are in there. You have a constraint that makes sure there's at least 5 sofas in there. You have, where's that other constraint? Where's the 800?
Or there.
You have a constraint that makes sure we don't go larger than the square footage available in the display. And we just heard that we want to maximize profit. This display is going to determine how many are sold of each. We want to maximize profit, so we wrote this objective function.
Yep.
Objective function, 1 constraint, 2 constraint, 3 constraints. Very easy problem. And then when we get to chapter 2, we solve what the optimal amount of couches and sofas to put in the display based on this information. This is what linear programming is. It's taking this whole story. This is a very easy example, just introducing you to it. But I need you to realize we're heading to where the examples are a little more difficult. Some are going to have 10 constraints with an objective function, not just 3 little constraints like this. And we got to get to the point to where you read a problem, you don't get this sentence that tells you what the variables represent. In quiz 2, 3, 4, in your final, you're telling me what variables you want to use. It could be a completely different variable than everybody else in this room, but your definition, what the variable represents, is the same as everybody in this room if they have that exact same problem. S is the number of sofas in the display. C equals the number of couches, not couches, chairs in the display. You have to come up with the variables and what they represent. And you can use any letters you want. You could have said x1 equals the number of sofas in the display. x2 equals the number of chairs in the display. That's where we got to get to. This first quiz you are taking with this Saturday, right? This Saturday? No?
Yes.
Is it this Saturday?
Yes.
I'll see you here, Hunter. We'll go hunting. For answers. All right. Are you ready? How are we doing? We good? Sign that signing sheet. Let me hand these back, and then you guys leave.